All right, for this test, the non-graphing calculator part, which will be the first part of the test that you take, you solve by substitution with two unknowns. There's one equation of that. Then using elimination to solve with two or three unknowns, there's two equations with two unknowns and two equations with three unknowns. And then you'll have to break down a partial decomposition problem. You won't have to solve that one, you just have to break it down. Then finally, on the graphing calculator part, which will be the second day, you have three-story problems on it. Two of them with two unknowns, one of them with three unknowns. And then you'll have one equation with two unknowns that you need to solve by graphing. And you'll have to sketch the graph and show me that. And then you'll have to complete a partial decomposition problem from beginning all the way to end. So let's look at all of the examples that we have here. In this first one, if you were going to solve by substitution, you have to either get x or y by itself, and it doesn't really matter, but we're going to take the second equation here and solve for x by adding y to both sides, and then you will get x equals y plus 3. Then taking that answer and substituting it into the first equation, you have 4 times y plus 3 minus y squared equals 7. Distributing the 4 will get you a negative y squared plus 4y plus 12 equals 7. And then if you subtract 7, and the reason you're going to subtract 7 is because when you have a squared term and a y term, or a squared term and a linear term, you have to set one side equal to 0 and then get everything else on the other side. So you have negative y squared plus 4y minus 5 plus 5. And at this point then you can use a quadratic formula if you want to, or you can try to factor it. And if you were going to try to factor it, I would turn this into a positive y squared, which then turns that into a negative 4y, and that into a negative 5. And that is still 0 because all you're doing is multiplying this whole equation by a negative 1, which is allowed. And so, can you factor this? Why, of course you can. And that becomes y minus 5 and y plus 1. And so in this case, y is 5, and then in this case, y is a negative 1. And now that we know that y is 5 and y is a negative 1, we can go back up to this equation and figure out what x is. And so because y was those two values, x is going to be 8 in this case, and x is going to be 2 in that case. And so then 8, 5 is a coordinate, and 2, negative 1 is the other one. And that's one way to solve it. Of course, you could try to solve for y in this case and then substitute it in, and then you'd get your x values first. Or get your y values first. It really doesn't matter. Either way, you're going to get those two answers. And so that's the one we're dealing with substitution. Now, if you want to use substitution on other ones, you can, but you don't have to. To me, substitution is a little bit more time consuming, depending on the problem. All right, so for this one here, we have 2 over x minus 1 over y equals 0, and 6 over x minus 2 over y equals 10. So first I'm going to multiply the numerator, or the top one, by 2, and that will get us 4 over x. And let's make it a negative 2, so a negative 4 over x plus 2 over y equals 0. And then taking these two equations and adding them, 6 over x minus 4 over x is 2 over x. And 10 plus 0 is 10, because a negative 2y and a positive 2y is 0. Now to solve this thing, multiply both sides by x first to get 2 equals 10x, and then divide by 10, and x equals 1/5. Now that we know x is 1/5, we can substitute that into any one of the two equations, and we're going to go into the top one, 2 over 1/5 minus 1 over y equals 0. And 2 divided by 1/5 is the same as 2 times 5, because dividing by a fraction is the same as multiplying by the reciprocal. So now you have 10 minus 1 over y equals 0. Subtract 10. Negative 1 over y equals negative 10. Multiply both sides by a negative y. And you get 1 equals 10y. And then divide by 10. And y is 1/10. And so now we know x is 1/5. Y is 1/10. And then you're done. All right, taking this one, 3 equations with 3 variables, and we have to solve them, and we already have y's opposite of each other, so let's take these two and add them together, and you will get 4x plus 7z equals 8. And the second equation that you would want to use would be that one, because that one already has y eliminated as well, so we've gotten it down to 2 equations with 2 unknowns. So now we have to combine them. Multiplying this one by a negative 1 first. So we get a negative 8, a negative 7z, and a negative 4x. And now adding that to this one, 4x and a negative 4x is 0. 2z and a negative 7z is a negative 5z equals negative 8. And then when you solve that, z is going to be 8/5. So we have that for our answer. Now we can take that and substitute it into any one of the equations that have z, which you would want to use either this one here or that one there, because you're just dealing with x. So we're going to go back up to this one, and we have 4x plus 2 times 8/5 equals 0. And 2 times 8/5 is 16 over 5. Equals 0. Subtract 16 over 5, and you're going to get 4x equals a negative 16/5. Multiply both sides by a 1/4. And x is going to be 4/5, because 4 goes into 16 4 times. And so then we now need to figure out y. So x is 4/5 plus 2y plus 6 times 8/5 equals 4. Solving this then, let's see, 6 times 8/5, that's like over 1, so 48/5 plus 2y plus 4/5 equals 4. So we're going to subtract 4/5 and subtract 48/5. So 2y is going to equal, and 4/5, or 4, is the same as 20/5. So 20 minus 4 minus 48 is going to be negative 32/5. No. Going to back up for a moment, because this is not right. Way back here, we made a mistake. Actually, not we. I made a mistake. This is a negative 16/5 times 1/4 should be a negative 4/5, which turns this into a negative 4/5, which turns that into a negative 4/5, which turns that into a positive 4/5, and then this would be a positive 4/5 as well. And And so now when you simplify that, that's 24 fifths minus 48 fifths, which is going to be a negative 24 fifths. There, that's much better. Then we have to multiply by a half. And then y equals, because 2 goes into 24 12 times, it's going to be a negative 12 fifths. So we know x is a negative 4 fifths. Y is a negative 12 fifths. And z is 8 fifths. And there you have your answers, or the answer. All right, now this one. And we have to eliminate a variable. Well, let's see. This one and that one, if you combine them, you would get rid of x. So let's add them together. That would be 0. That would be a y minus 2z equals 5. So now we have a y and z left, so we have to get rid of the x again. So I'm going to take this one and multiply it by 2 to get a negative 2x plus 6y minus 6z equals 22. And then I'm going to combine it with that one to get 0x, 3y, negative 6z, and 15. Now I have two variables with two equations, so I'm going to multiply the top one by a negative 3 to get a negative 3y plus 6z minus 15. Combine them and you will get 0 equals 0, which is infinite solutions. And when you get a one with infinite solutions, you got to figure out where the ordered pairs are at. So the first thing you do is say that z equals a. Remember, you can let any of them equal a, but it's always nice to you do z because that's the way it's going to be in the answer. So we solve for one of the other variables by using one of the equations that has two variables in it, like this one right here. It is y minus 2a equals 5. Adding 2a to both sides gets you y equals 2a plus 5. So now we know z is a and y is 2a plus 5. So then we have to substitute those two things in to figure out what x is, and we're going to use this top equation. So x minus 2 times 2a plus 5 plus a equals negative 6. Distributing, you'd get x minus 4a minus 10 plus a equals negative 6. So adding 4a, adding 10, subtracting a. So adding 4a minus a plus 10. And you're going to get x equals 3a plus 4. And so then our ordered pair is 3a plus 4 for x, 2a plus 5 for y, and a is for z. Now what that says is that any value you pick for a, say 10, then this one becomes 25, and this one becomes 34. There is a coordinate that is part of the infinite solutions. All right, then we have this one with an inheritance of $20,000 and is invested into 3 investments that yield $17.80, and the interest rates are 7, 9, and 11. Find the amount for each if the second and third are 3 and 1,000 less than the first. So first off, you got to have variables. X represents the amount invested at 7%. Y represents the 9% investment. Z represents the 11% investment. Now, starting with this number right here, you have a total of $20,000 to invest. So X represents the amount invested at 7%, Y and Z. So you have an equation of X plus Y plus Z equals $20,000, because all of the money is being invested into three different things. Then moving down the sentence, it says you get $1,780 from the investment after a year. Well, if it's 7% per year and you invest X amount of dollars, that is 0.07X. That's how much you earned from this investment. Then for the second one, it would be plus 0.09X. And then the third one is plus 0.11x equals 1,780. Then you have a couple more equations that you can write. And in this case, there's 4 equations that you can write. You really only need 3 because you have 3 unknowns. We'll write all 4 of them. So it says find the amount invested. The second is 3,000 less than the first. So the first is X minus Y is equal to 3,000. And the other one is the third is 3,000 or is 1,000 less than the first. So X minus Y is 1,000. Now you can also say that, or not, it's not X minus Y, this one is X minus Z. Another way to write this, and probably the way you would think of writing it first, is Y equals X minus 3,000. And then this one is Z equals X minus 1,000. But if you're going to use elimination, you got to get them in the same order. And so that's why we've written them as X minus Y equals 3,000, X minus Z equals 3,000. Okay, so you have 4 equations here. You only need to use 3 of them. The one I would stay away from because it has the decimals and everybody's afraid of decimals just like they're afraid of fractions would be that one. So instead use this one, and that one. All right, so if we get rid of the y in, so we have, let's say we would take this equation and this equation and we add them together, we are going to get 2x and the y's go away plus z equals $23,000. So we've gotten rid of the y. And here's another equation that has y gone, so x minus z equals 1,000. We can just add those together. And you're going to get 3x equals $24,000, which then turns into x equals 8,000. And so if x is 8,000, then I would go to this equation right here, or even this one over here since you changed it. Either way, you have 8,000 minus x equals 3,000. So x is 5,000. Oh, got that backwards. No. It's y. Hello. So y is 5,000. And then do the same thing for the other one. 8,000 minus z equals 1,000. So z equals 7,000. And so those are the three answers. And so then at the end, you got to write your answer. You invested 8,000 at 7%, 5,000 at 9%, and 7,000 at 11%. That number there, those should all total 20, which they do. And if you were to take these numbers and add them up, that would total 1780. All right, moving on. Set up a business and make an initial investment of $10,000. The unit cost of the product you make is $285 and the selling price is $495. How many units must you sell to break even? Break even, okay, so you have expenses and your revenue. For expenses, you spent $10,000 plus you have to spend $2.85 per product unit that you make, where X is representing the number of units. The other equation for the revenue, you get $4.95 per unit. And if you're going to break even, these two things have to be the same. So your equation becomes 10,000 plus 2.85x equals 4.95x. Solving for x then, if you subtract 2.85 from both sides, you're going to have 10,000 equals 2.1x. And then if you divide by 2.1, x will equal 4,761.9. So now you have to break even. You can't make 0.9 of a product. So then you need to sell 4,762 units. And then the last one on the story problem deals with revenue from a video store on a particular evening was $867.50, and you sold 310 units. Movies are rented at a rate of 3 per movie, and video games were $250 per game. How many of each type were rented? So you have X equals movies, Y equals video game. So first off, you know that you sold 310, so X plus Y is equal to 310. And you also know that you had $867.50 for profit, so $867.50 is your total amount. And you get $3 for movies and $2.50 for video games. And so now you have to solve these two equations. Of course, you get to use your handy dandy calculator on this part, so then you could take it out and put in your simultaneous equations 1, 1, 3, 10, 3, 2.5, 8, 67, 50, and then solve it. Or you can try to eliminate by multiplying this one by a -3 to get a -3x minus 3y equals a -930. And then add them together, and that becomes a -0.5y equals 62.5, and so then y is equal to 125. Because you got to divide by 0.5 or multiply by 2. And so then if y is 125, x plus 125 equals 310. Subtract 125, and x equals 185. And so you have 185 movies and 125 video games were sold on that particular, or rented on that particular day. Okay, these last two are dealing with partial decomposition, and we're going to go through the whole thing in both of them. One of them you won't, like I said, on the first day you only have to do the part. The bottom here is already factored. If it wasn't factored, you'd have to factor it. And so this becomes a over x plus b over x squared plus c over x plus 1. And remember, anytime you have something like this, x squared, it's got to be every exponent below it. All right, so we would be done with it on the first day. That's all you would have to do. Of course, I'm not going to give you one where it's already factored for you. You're going to have to factor it out. So you'd probably given this to begin with. And then you have to break it down to x squared times x plus 1. And then you would write that. It's not going to be that easy. It's still pretty easy anyway. All right, so then multiply the whole thing by x squared times x plus 1. When you do that, the x still goes into x squared x times, so you have ax times x plus 1 plus, now x squareds go away, b times x plus 1 plus, now the x plus 1s go away as cx squared. Distributing, you get ax squared plus ax plus bx plus b plus cx squared. And over here on this side, you would have 4x squared plus 2x minus 1. Combining the squared terms and factoring out an x squared, you would have a plus c. Combining the x terms and factoring out an x, you would have plus a plus b x, and then plus b at the end. And so now your x squared term is a plus c coefficient. Here it is 4. So you have a plus c is equal to 4. You have a plus b, which is equal to 2. And you have b, which is equal to a negative 1. And again, you can take your calculator out and put that all in, because here you have b is 0, here c is 0. Here you have a and b, or a and c being 0, but you already know b is a negative 1, so if you substitute that into there, you have a plus a negative 1 equals 2. Add 1, a is equal to 3. Use the top equation then, 3 plus c equals 4. C is equal to a negative 1. And so then you can write the partial decomposition. Since you know a, b, and c, you will get 3 over x minus 1 over x squared. That's supposed to be a positive 1. And then plus 1 over x plus 1. And there's your partial decomposition. Okay, last question, same type of thing. Again, it's already done. Then in yours it would be x cubed minus x squared minus 2x squared plus x. And then you factor out an x first, you get x squared minus 2x plus 1, and then the factors for that are x minus 1 squared and x, because it's x minus 1 times x minus 1. That's how it would start for you. And I'm not going to give you one where the denominator is smaller, where you have to do that dividing. So you have a over x plus b over x minus 1 plus c over x minus 1 squared. multiplying the whole thing by x times x minus 1 squared. Left-hand side is just going to be x squared minus x minus 2. Here the x's go away and you have a times x minus 1 squared plus b times, b times x minus 1 plus c times x. Because the x minus 1 squareds go away, so you're left with c and x. Here an x minus 1 goes away. You still have an x minus 1, so b times x minus 1. All right. Squaring this gets you x squared minus 2x plus 1. So you have ax squared minus 2ax plus a. Multiplying that out plus bx squared minus bx plus cx. X squared terms are this one and that one. And you have a plus b. The x terms are this one here and this one here. So minus 2a or plus a negative 2a minus bx. Oh shoot, I missed the c. Let me start that part over. There's also a c here. So take an x out. Get a negative 2a minus b plus cx, and then the only other one is plus a. And that has to equal this x squared minus x minus 2. And so a plus b is equal to 1. Negative 2a minus b plus c is equal to a negative 1. And a is equal to negative 2. And so now we know a is a negative 2. We can just substitute that up into this equation. So now you have a minus 2 equals 1. Add 2. And a is equal to 3. And then, since a is equal to 3 and my goodness, I'm going too fast. It's because the bell rang and I have to try to get this done before my next class arrives. So negative 2 plus b equals 1. So b is equal to 3. That's much better. So now we can substitute those two things into the middle equation, and you have a negative 2 times a negative 2 minus 3 plus c equals negative 1. So that's a negative 4 minus 3 plus c equals negative 1. No, that's a positive 4. Okay, so subtract 4, add 3, subtract 4, add 3. And c is going to equal negative 2. And so then your partial decomposition will be negative 2 over x minus 2 over x minus 1 plus 3 over x minus 1 squared. And then that is your final answer. And that would be the last of the review problems, which would look like what is on your test. So we are done.